So this video lesson is all about the order of operations. And for us, the order of operations is going to be thought of a little bit differently from a way that you have probably heard about it before. We'll still use the same acronym. We'll still go through it in essentially the same way, but the way we're going to think about it and the way that we are going to understand why it is the way it is going to be slightly different from a way that you've seen before. Before we can get into actually the order of operations, as we call it, we have to first talk about what an order of operations at all is. And really, the words that make up the phrase say it all. It has to do with those operations, the fixed ways we manipulate numbers, rather, and it tells us the order that they happen in. Now, you don't have to write that in particular down, but that's what the idea of an order of operations is. It just tells us the order that we have to do particular things in order to come up with an answer. And this is particularly important because we want to make sure that everybody who looks at a problem around the world ends up with the same value for a calculation regardless of where they are. It wouldn't be a very good system if you could come up with 4 or 5 different answers or even 2 different answers to the same basic calculation problem where there's no uncertainty and there's no changing values. And we'll see a little bit about what that means here in just a second. So let's take a look here at the idea of 4 plus 5 times 3 minus 12. And this gets to that point that I was saying in terms of why we need an order of operations. Well, if we go from left to right, we would end up at 9 times 3 minus 12. 9 times 3 is 27 minus 12, and we would end up with an answer of 15. But if we did multiplication first, as we may have learned through our lower school or elementary school experience, then we're going to need to do the multiplication first. That becomes 4 plus 15 minus 12. 4 plus 15 is 19, and 19 minus 12 is 7. Now, in this particular calculation here, where there is no uncertainty, we need to be able to say that we have one particular answer. That answer, it just so happens, is 7. But we can't have people coming up with multiple different answers and calling it a valid calculation. Everybody who goes through this problem should be able to come up with the number 7. So we need to have an order of operations to tell us that the multiplication comes first. Now, the way that you've heard it said before is probably something along the lines of PEMDAS, although we're going to add a little piece down here with the FB, and we'll get to what that means in just a second. But you may have seen PEMDAS, heard it by its way of remembering it. It's mnemonic. Please excuse my dear Aunt Sally, and then we're going to add for burping. But the order of operations themselves, each of those letters stands for a particular operation or a particular symbol. From parentheses, exponents, multiplication and division, addition and subtraction, and finally a fraction bar. So go ahead, pause the video, write down this order of operations. You can write down the mnemonic if you want to also. Write down both the letters that we use to start them and what those letters actually stand for. And when you're done, unpause the video and we will move on. So you'll notice a few things here. The M and the D, as well as the A and the S, are grouped together and they don't have a space between them. That's because when we go through our order of operations, multiplication and division happen in the same step, and addition and subtraction happen in the same step. We don't do all the multiplication before all the division, and we don't do all the addition before all of the subtraction. That's not really how it works. And the reason that we can understand how it works is based on the way that math is structured. When we think about problems in math, there are a lot of different ways that we can think about them. First, we can think about it as containing a bunch of different types of operations, parentheses, exponents, multiplication, division, etc. And then we just go through them in a particular order, and we'll talk about in class why that order is the way it is from a purely operational standpoint. But the other thing that we can talk about is, what does it mean to break down a problem like that? Now, in the problem of 4 plus 5 times 3 minus 12, this problem is actually telling us that we're adding or subtracting 3 things together. The 4, the quantity 5 times 3, and then we're subtracting a 12. The most basic types of operations that we have addition and subtraction separate our problems into chunks that get added or subtracted together. And that's why they happen at the end. Because after we've separated our problem into chunks based on addition or subtraction, then we simplify all those chunks with the other operations, and then we finally add or subtract them together. This is not just things that happen from left to right. It's three distinct quantities that are being added or subtracted together. That's why those are last, because that's how we break down our problems into chunks. Before that, with the multiplication and division, these are lots of things that happen inside those chunks. If you don't get to add or subtract things right away, then we're probably going to have to do some multiplication or division. And so those happen before addition or subtraction to simplify those down. But really, before all of that, we have special types of operations, parentheses and exponents, and we have to take care of those first. Because if addition and subtraction breaks it into chunks, and multiplication and division manipulate them, parentheses and exponents are really just there to talk about or to separate those operations into very particular special set-aside units, which is why we do them first. So let's take a look at what that actually means in terms of some operations. You don't have to write this down, but you can just follow along here. So here in this problem, 12 minus 2 times 3 plus 8, we see that we have a multiplication here that's in the middle, and it's between an addition and a subtraction sign. Now, if we go from the order of operations from top to bottom, first thing we'll see is multiplication, so we should do it first. If we think about it in chunks, we see that it's a 12 and an 8, and in between them, between the subtraction and addition, we have a 2 times 3, or a 6. And so 12 minus 6 is 6, and 6 plus 8 is 14. Let's take a look at it in a slightly more complicated scenario here. Here are order of operations, again, following from top to bottom, from parentheses down to fraction bar. We still don't have any fraction bars. The first thing we would see is the parentheses. And the parentheses are setting aside the 5 minus 2 and say this is a unique thing to itself, so we need to take care of that first. That's 8 times 3 plus 12 divided by 3. And now, our addition here says that we're taking 8 times 3 and we're adding the value 12 divided by 3. If we're looking at our order of operations from top to bottom, multiplication and division happen first from left to right. 8 times 3 is 24, 12 divided by 3 is 4, and 24 plus 4 is 28. So either way you look at it, either just following it from top to bottom, or thinking about it as the addition and subtraction, splitting the problem into chunks that we need to work on, both of those are correct. And so finally, one more complicated one. You can see that there is a fraction bar here, separating it into a numerator and denominator. And what that means, why it's at the end, is that we're just going to do the numerator and denominator calculations first, and then we're going to go on to the rest of it. So again, parentheses and exponents need to be taken care of in the first step. 6 divided by 2 is 3. 2 squared is 4, so this is 3 plus 5 times 4 minus 3. And at the bottom, we don't have any parentheses or exponents, so it's just 4 plus 6 times 1. Now again, we look at chunking or multiplication and division first, but these multiplications and divisions need to be simplified because they're quantities being added and subtracted around it. So that's 3 plus 20 minus 3, which ends up at 20. 4 plus 6, which ends up at 10. And a fraction bar means division. So 20 divided by 10 is 2. That fraction bar, that last step there, that we use as a division, we use as another way of representing division, is there at the end because it takes the quantity of a numerator and a quantity in the denominator and then finally divides it out. Now, this is going to be a unique video lesson compared to others we've done so far. I'm going to leave these problems here so that you can go ahead and take a look at them, and then it will be your turn to practice by simplifying each of those 5 expressions that we have here. We're not going to actually go through the answers in the video. If you're confused by the parts of the order of operations, I encourage you to go back and look at the video again. We'll actually come in, the first thing we do in class after we've taken our check-in is we'll put these up on the board and try to break down why each of these problems is the way it is. So go ahead now, pause the video before the video actually finishes, write these problems down, and do these 5 problems in your notebook. We'll look at them right when you come into class in the morning or afternoon.